Alright, this video is the fifth in this factoring set of tutorials. First was GCF, second was sum and difference of squares, third is standard form, which is the ABC, where a is equal to 1. The fourth one is a standard form where a does not equal to 1. Alright, we're talking today, in the first one, about the sum of cubes and the difference of cubes. I ask you to recall that when you are speaking about special patterns for squares, you can only do the difference of squares. This one here, I jokingly drew this figure being near Halloween and said, don't do this. Do not touch. They don't factor apart. The difference of squares absolutely does. However, when you're talking about sum of cubes and difference of cubes, they both come apart. This, however, needs memorization. So, first, here is the pattern, or maybe the formula, that you would need to remember for the sum of cubes. If you have a sum of cubes, where you have a cubed plus b cubed, it will separate into two parts. It will separate into a plus b as a first binomial. The second trinomial would look like a squared minus a times b plus b squared. So it would be important to know what the a value and the b value are. I want to compare that with the difference of cubes pattern. It's going to be exactly the same. If you have the difference of cubes, it'll separate into two parts, a minus b, and then the pattern a squared plus ab plus b squared. In order to try to make it easier to memorize, I want to say that the entire pattern is the same except for two locations, here and here. Notice that when you have the sum of cubes, the plus sign is replicated in the front, whereas the very next symbol is going to be subtraction. When you're talking about the difference of cubes, the difference or the subtraction sign is in the binomial, whereas the plus sign is reversed and is the first term in the trinomial. It's just like these two symbols here are reversed depending on if you're talking about the subtraction or the difference of cubes and the sum of cubes. Everything else is exactly the same. Knowing when the plus leads or when the minus leads is important. Alright. Two more things before we get going on this. Proof that these work. Well, if I were to take this expression here and to check and see if it actually works, I could multiply this out, and what I would have would be this. I'm going to write the problem quickly. So there's the multiplication problem just written out so that we're able to multiply it. I'm going to distribute a binomial to a trinomial. Alright, so this a is going to multiply here, giving me a cubed. The a will follow and multiply here, which will be a squared b. Notice I have a times a and then just b. Lastly, this will multiply all the way to the back, and I will have plus ab squared. Now, please notice that this the middle term here has a squared and b to the single power, whereas the third term is a to the single power b squared. I'm going to switch colors. I'm going to multiply with the b. Coming underneath, I would have b times a squared, or a squared b, but it would be positive. So here, positive a squared b. I will have here b times negative ab, which would give us a negative ab squared. And lastly, reaching all the way to the back, I would have plus b cubed. Now I'm going to get myself more paper here. Notice how I stack the two trinomials in a way that I can combine like terms. This a squared b column actually cancels out to make 0. You have negative 1, you have positive 1. The ab squared value, or column, does the exact same thing. Positive 1, negative 1 makes 0. This center section is eliminated. The only two parts left are a cubed and the positive b cubed. Everything else has disappeared, canceled out. So what I have is simply the sum of cubes. It would be interesting for you all to check to see how the difference of cubes works. On your own would be a good idea. Now, the other part that would be necessary or useful to talk about is, what are perfect cubes? Well, perfect cubes are any number that is, for example, this would be 1 times 1 times 1. With this case, it'll equal to 1. 2 cubed is going to be 2 times 2 times 2, which will equal to 8. It's useful to know this list, so I'm going to write some of these on the side here. 3 cubed is going to be 3 times 3 times 3, which is going to be 27. 4 cubed, same, will be 64. 5 cubed will be equal to 125. 6 will be equal to 216. 7 will be equal to 343. And 8, this is probably much larger than we ever need. 8 times 8 is 64, 512. So the reason for having this list here is to know if we see an 8, it is actually 2 cubed. If we see a 64, it's actually 4 cubed. Having this list handy, or simply understanding that you can divide by, you can cube root, will also help. So, what I want to do is actually work this 125x cubed plus 8. Let's go to the next page. So I have here 125x cubed. I'm going to make this a little bit, that's too much. To the height. There we are. 125x cubed plus 8. Doesn't look much different. This is a sum of cubes, so I'm going to follow this pattern here. So if I were to work with 125x cubed, I'm going to look in my list and I'm going to see, oh, the numbers disappeared. Hold on. Sorry about that. The bases for the first several disappeared. I'm going to notice that 125 is actually 5 cubed. So this can be written here as 5 x cubed added to, and I see that 8 is going to be 2 cubed. So I think that this red writing demonstrates that it actually is the sum of 2 cubes. Alright, what I have here is simply 5x multiplied to 5x multiplied to 5x. On this far side, I would have 2 multiplied to 2 multiplied to 2. For this particular problem, in terms of a and b, a would equal just the 5x. b would equal just the value of 2. It's good to identify the a and the b. So, writing it over here, we have 125x cubed plus 8. If I were to write that a was equal to 5x and b is going to equal to just the value of 2, now I understand that this quantity here is going to go everywhere I see the a. The quantity 2 is going to go everywhere I see the b. Notice this part's going to have a b squared, this part's going to have an a squared. So I simply fill this pattern here, fill up this with the a's and the b's, and pay attention when I have to square them and when I don't. So let's get that underway. Here's my first binomial, and it's going to be addition. In the front, we'll set the a, which is going to be 5x. In the back, we'll set the b, which is going to be 2. I'm setting up another another parenthesis set with a trinomial. Now, what I have to do here is I have to take the entire a value and square it. So what I'm going to do is I'm going to have 5x, that's my a value, but I must take that quantity and square it. So notice I put it in another set of parentheses to square it. Then I will have, need some more space, a little bit more parentheses. I will have the a, which is going to be 5x, and that's going to be multiplied to the value of b, which is going to be 2. Notice I'm using parentheses for the multiplication. In fact, what I'm going to do, I'm going to take this parenthesis piece here and make it larger and taller. So this one's going to be this way to separate it and make it look distinct and not confusing. Now, in the back, notice this is subtraction here. In the back, I'm going to be adding the b squared. In this case, it's going to be the value of 2, but that 2 is going to be squared. Now what I need to do is to look inside of this trinomial and do a little bit of simplification, and we'll be done. So, this expression here, 5 squared, is going to be 5x multiplied to 5x, which is going to give us 25x squared. The expression here is negative 5x times 2, which is going to be equal to negative 10x. Lastly, in the back, this expression here is 2 squared, which is really 2 multiplied to 2, and this is going to give us a positive 4. This, when I bring down the initial binomial of 5x plus 2, is the complete factorization of 125x cubed plus 8. Here, we are finished. We can check this in the calculator, as we had before, by typing this red quantity here, the original problem, into y1. We would type this final product here into y2, and we would compare the two lists. So here we have the calculator, and I'm going to go ahead and press y equals. Now, in interest of time, I've already typed in 125x cubed plus 8. I've typed in 5x. I'm just going to show 5x squared, or I'm sorry, 5x plus 2, and 25x squared. Just checking all of this. minus 10x plus 4. If I were to press second and graph, I will see that my y1 list is huge, but it matches identically my y2 list, indicating that I've correctly factored this sum of cubes. All right? Let's work the same process, but with a difference of cubes. All right? So, in this case, I see that 64 is really going to be 4 cubed. So I have 4x to the power of 3 if I need it. 27 is going to be 3 cubed. That's going to be 3y. So it's going to be 3y cubed. Now notice what I'm doing. What I'm saying really is that this is going to be 3y multiplied to 3y multiplied to 3y. This is my b value here. It's b times b times b. My a value is going to be 4x multiplied to 4x multiplied to 4x. Looks like a 9. 4x. So a is going to equal to 4x. b is going to equal to 3y. This is going to be interesting a little bit. All right. So I'm going to use these a and b's to fill up the pattern. I'm going to need some space here. In the front, I have this. It is the subtraction of just a and b. In this case, a is going to be 4x, and b is going to be equal to 3y. Now, this next set of parentheses I'm going to make larger and taller so as to make it distinct from the interior parentheses like I'm going to use. The a value needs to be squared, so I'm going to take 4x, but I'm going to square it. I'm going to put the whole a value in there and set a parenthesis or a power of 2. Next I'm going to add. Remember, we are following this pattern here. I'm going to use a, 4x, but I'm going to multiply it to 3y. Notice it's all in parentheses. Lastly, I'm going to take the b value, 3y, and put it in parentheses with a power of 2 on it. I'm going to close this whole large quantity here. Then what I must do is I must simplify. So I'm going to take this expression here, and this is really going to be 4x multiplied to 4x, which is really going to be 16x squared. This middle is going to be 4 times 3, or 3 times 4, which is going to give you, I should say positive 4 times 3, gives you positive 12xy. This part here is really 3y multiplied to 3y, which is going to be 9y squared. There is no more work to do inside these parentheses, so I'm going to reestablish them here. I'm going to copy the binomial in the front and close it off. We could also check that this creates the original 64x cubed minus 27y cubed. This one would be more difficult to do in the calculator because of the presence of the y. If you get the concept, you're welcome to begin practicing. A couple more examples here. So here I have 8w cubed plus 27. Another way to go about this is you could calculate the cubed root of 27. Now, where would you find the cube root in the calculator? Here's the calculator. We're going to quit this. Cube root is going to be here in math. You can press math. You're going to see option 4. And then I could type in 27 and indeed prove to myself that the cube root of 27 is in fact 3. What that means is that 27 is going to, this equals to 3, which means that 27 is really going to be 3 multiplied to 3 multiplied to 3. Cube root of 8 that's going to equal to 2, which is going to be 2 multiplied to 2 multiplied to 2. However, this is a w cubed, so I need to include the w's in each of the terms. So it would be 2w multiplied to 2w multiplied to 2w. A is going to equal 2w. B is going to equal to just 3. It's a really good idea to write down what A and B are equal to. All right? Now we need to remember what the pattern is. It's the sum of cubes. So I'm going to say that it will be A plus B. Then the pattern is going to be A squared. Subtract A multiplied to B plus B squared. You need to memorize this if you're going to be successful with this. All right? Now it just is a matter of putting the A and the B in their proper places, noticing when to square them and when not to. Here, pardon, I'm going to put in 2w plus the B, which is going to be 3. I'm going to close this first parenthesis. This next one I'm going to make it taller because remember I'm going to use some parentheses inside parentheses. So here I'm going to use A squared, which is going to be actually 2w, but that is going to be squared. Subtract, using parentheses to indicate the multiplication, 2w multiplied to 3, and then plus the b, which is 3 squared. Now I'm going to close off with a larger set of black parentheses. Move this down. Alright, so what I'm going to do next is simplify on the inside here. This really is going to be 2w multiplied to 2w, which is really going to be just 4w squared. This is going to be negative 2 times 3. That should give us negative 6w. Here is going to be 3 multiplied to 3, which is going to give us a positive 9. This is going to be placed back in parenthesis, and we're going to bring down the binomial here to w plus 3, and we are finished. And this is the way the pattern will continue again and again and again. The one thing they might try to do is to put a GCF in one of these. It didn't happen in either of these cases. So if you get the concept, you're welcome to stop the video and begin practicing. What I'm actually going to do, I'm going to pause the video, and I'm going to work number 5. You can pause it, and then see if you come up with the same thing. We'll probably do the same with 6. So I'm going to pause it. Well, I said to pause it, but then I also said that this is probably not going to happen with a GCF. I wasn't quite correct. I wasn't paying attention. You should divide by 2. You should divide by 2. This is going to give us a GCF of 2, which then is going to give us just z cubed subtract 125. Q cubed. Now we can work the interior. Wasn't quite thinking. It's a little bit late. Now we're able to work this as a difference of cubes. Work this inside part, see what you'll come up with. Now I'm pausing it for real. Alright, so this is partly done. Alright, I went ahead and worked it. You see that I've taken the z cubed and separated into 3 z's, or you could take the cube root of it. I did the 125 and it's 5q, 5q, 5q. I wrote down what the A and the B are equivalent to so that it made it easier to put them into the pattern. Notice also the details I'm talking about here with my parentheses, keeping my multiplication organized. Then I go ahead and write my final product here, and I am finished. Alright? We'll call that good. If you have any questions, please ask.